Good morning, everyone. John Powell here from SMC. I'm one of the automation specialists at SMC Electric, and today we're going to try something a little different. We're going to do a virtual sensor training, and we're going to start out talking about photoelectric sensors. Uh, Basically, when you look at a photoelectric sensor, it is made up of four components. There's a light source, a light detector, a sensor logic circuit, and an output device. The source of light, like I said, typically light emitting diode. It's available in typically multiple colors depending on the target you're trying to see. So they're available in a visible red, green, or blue, and also in an infrared, which would be invisible. Again, low power consumption is one of the advantages. Long life, since they are a solid state device. Also shock and vibration resistance and very high speed switching, particularly in DC applications, very high speed switching. As far as the light detector, typically it's a photodiode that's used as a light detector. And used for the same reasons, it's a solid state device, very efficient and very quick switching. The sensor and logic circuit basically will take and sense the change in the modulated light received by a photodiode from the LED, causes the output device to change state. Many include on-off, timing delay functions, or other logic functions. Basically, logic circuits take and amplify the signal from the light detector, and together with the logic and timing functions, if those are on board the sensor, they determine whether an output should be generated. These functions were originally accomplished using electron tubes, but modernization gave way to discrete transistors, which in turn gave way to surface mount devices, which also gave way to integrated circuits. The output device translates that relatively weak signal from the sensor into a real-world power switching capability for driving loads directly or interfacing to high-speed logic such as your PLC controllers. Output devices can vary quite a bit. There's a lot of different things there. As we mentioned earlier, electromechanical relays, pretty reliable, but maybe kind of slow. So when you get into speedy applications, you want to look at solid state, triacs, FETs, power MOSFETs, transistors. They can be done either as sink or source type loads, PNP or NPN, depending on the device. Many of the new devices are auto ranging as far as whether it's a sink or source load, and so they pick it for you in many of the newer devices. If you look at the way a typical circuit works, say you have a light source that is on all the time. It is a modulated source, so it's sending that modulated beam out at a certain wavelength. The photodiode is looking for that specific wavelength of light. When it sees its light, it's gonna have an output. If it's set up for the output to be light operate, if it's a dark operate, it won't have an output until something breaks that beam and stops the light from reaching the photodiode receiver. As I said, that it does use a modulated light source, and the receiver is tuned to look for that particular modulated light source, so that helps improve the immunity to ambient light. In a modulated circuit, the LED is pulsed at a very high speed, 1,000 to 40,000 hertz typically. The receiver again is tuned to respond only to that specific range of modulated light. The short duty cycle of the modulated light allows the LED to be pulsed at higher power to improve operating range and margin. If you look at a retroreflective or diffuse mode, let's say, you might have both those devices, the light source and the receiver, in the same device, so that it's putting out a beam of light. In a retroreflective mode, you would have a reflector that would catch that light and reflect it back to the device. That would be retroreflective. So it's working off a reflector. The advantage of this might be that you have less stuff to wire. If you're in a transmitted beam mode, you wire two devices. In a retroreflective mode, you only wire the one device. And you can have it either something breaks that beam between the device and the reflector, and then you have an output. There's also a mode that's called a diffuse mode. When you're using diffuse mode, it actually is reflecting off of your target. So let's say I've got cans going down a conveyor and I want to see those cans going by. I could use either the retroreflective mode with a reflector across from it. Every time a can came by and broke that beam, I would get an output. Or I could use a diffuse mode, and every time the device saw a can, it would get a reflection directly from that can, and that would give you an output. So several ways to accomplish the same thing.